Hi, and welcome to Unit 4, Day 11. This is Part 3, where we're going to learn about the likes dissolves likes rule. So recall at the beginning of this unit, we learned about properties of metals, ionic compounds, and covalent molecules. And for covalent molecules, when it comes to their solubility, whether they can dissolve in water or not, we need to know if they're polar or nonpolar. So remember that polar molecules dissolve in water, so they're soluble. And we know that they're soluble because when you mix it with water, you can't tell the difference between the molecule and the water, right? It all kind of looks like one thing. On the other hand, nonpolar molecules do not dissolve in water. They're insoluble. It will look something like this, like sort of chalky or whatever. They're insoluble. So where does this idea come from? Polar molecules being soluble in water and nonpolar insoluble. Well, that all has to do with this what's called likes dissolve likes rule. So things with similar polarity or like polarities will dissolve in one another. So since water is polar, it will only dissolve polar things. And that is why most polar molecules are soluble in water. For example, water will dissolve HCl because HCl is polar, but it will not dissolve C6H6 because C6H6 is nonpolar. All right, with that understanding, see if you can answer this question. Oil does not dissolve in water. So is it polar or nonpolar? And explain. All right, so the answer is what oil must be nonpolar because remember, water is polar. And according to the likes dissolves likes rule, water will only dissolve polar substances. Since oil does not dissolve in water, it is nonpolar. All right, now we're going to try this CFU. Which of the following molecules is insoluble in water? Now, hint, what you're going to need to do is do the stuff that you learned in part 2. So you first need to determine if the molecule is polar or nonpolar. Now, remember, if you're dealing with a diatomic, a molecule with just 2 atoms, you're using the electronegativities and their differences in electronegativities to figure that out. So this table here and this table here. On the other hand, if you're dealing with a molecule that has more than 2 atoms, then you're going to use this checklist. All right, pause the video now. When you press play again, the answer will be revealed. The answer is C. So if we go through each of these, first starting with choice A, where since it has 4 molecules, 4 atoms, we would use this nonpolar checklist, and it's polar because not all the terminal atoms are the same. On the other hand, with B, we would, since it just has 2 atoms as a diatomic, we would use the difference in electronegativity chart. And using that chart and subtracting the electronegativities, we get that this is polar. For choice C has more than 2 atoms, so we use the checklist. And in this case, this fits that the hydrocarbon exception, which is all hydrocarbons are always nonpolar. So this one's nonpolar. And then finally for choice D, this one fits the other exception, which anything with a charge is always polar. Since there's a charge on the outside here, we know that this is polar. So this would dissolve in water. So the only thing that's not going to dissolve in water is a nonpolar molecule, and that would be choice C. All right, so that is it for this video. We are done with day 11. You've got an exit ticket to take, and then the rest of this time is work time for you for your project. Have a quality day.